Gurraj.
My name is Ningraj.
My name is Nitin.
Our previous topic is on basic on home automation. These are the contents. So introduction, circuit diagram, components, challenges, phase, results, future scope and improvements, conclusion and references. In the introduction, this project is simple explains about the temperature-based home automation system, which with the using of ESP32, which is an temperature sensor with a DC fan. The system automatically turns the fans when the temperature is high or low and switches it off when the temperature drops. It ensures comfort and safety with energy. It demonstrates how IoT concepts like sensing, processing and automatic control can be further expanded with the Wi-Fi module or mobile app features. The components are ESP32, which is a microcontroller. Here we have temperature based sensor, that is DHT11 or LM35, and we have a transistor or driver board and a DC fan with a voltage of 5 volts or 9 volts. Here in circuit diagram, the temperature sensor which sends in the temperature sensor, it detects whether detects the surrounding temperature and sends the data to the ESP32, where the ESP32 will check whether the temperature is high or low. If the temperature is high, the GPIO4, which is the general purpose input and output 4, will send the data to the transistor. If the temperature is high, the transistor driver board will turn on and the motor will start on the fan. If the ESP32 sends the data is low or the temperature is low, again the GPIO4 will send the data to the transistor or the driver board, and the driver board will turn off and the motor will turn off the fan.
Components used hardware microcontroller used Arduino ESP32 with the Wi-Fi module, sensor and actuators DHT11 and relay module to control the appliances. Power supply 5 volt regulated software requirements, programming application Arduino IDE and dashboard for the IoT platform. Network requirements, Wi-Fi connection, stable Wi-Fi connection. Problems faced, power supply issues. Voltage mismatch can damage the components or the system behavior. This can be solved by using a regulated power supply. Component compatibility, sensors, relays and microcontrollers don't often always work smoothly. So using a similar voltage, we can solve this. Real-time performance, ensuring quick response when a device is controlled remotely. Limited range, Wi-Fi coverage may not be sufficient for large homes. Using a Wi-Fi extender can solve this. Safety testing, ensuring safe operations with the electrical appliances.
Results. Finally, project is concluded after the system successfully automated appliances controlled based on the sensor inputs. So the device works on the sensors. When we give the inputs to the sensors, it build a connection between the devices and the microcontroller, and the process will go on. Next, accurate and reliable operations were observed under the different environmental conditions. The device is used in every conditions, have to perform a good condition. It track the every work on this project where the devices are working properly or not. Manual effort was reduced, improving the user convenience. This project reduced the manual usage of a user. It reduced the time and built a good interface using the mobile. He can use the devices. Energy consumption was optimized through automatic operations. By using the sensors specific for the on, when the user needs that device, it will on. In other time, it will reduce the energy and the users according to the user input and output. The project demonstrates effective uses of the sensors and the microcontroller in the real-time applications. This finally conclude that it is a good usage of a good electronic device used to save the time and money and give the good interface to the user. And the future scope improvements are integration with the IoT platforms for the remote monitoring and the control using the mobile applications. As we know, if this project can be more improvable by adding the more advanced sensors and the applications by using these devices. Next, addition of voice control using the smart assistant for hands-free operations. By using the AI models, we can add the AI models to this device to control the devices through voice. And the uses of advanced sensors for better accuracy, safety, and the energy management. For the dependence of the expenditure, we can improve the device's quality and may use the good performance. Implementation of a security features such as instruction detection and the alert notifications. We also provide a security for the user. The user can only access his device. He had the all control in your devices. Next, expansion to control multiple appliances and the room centralized automation. By improving, we can also cover multiple devices and applications through our centralized home automation.
To conclude on our project, basic home automation. Basic home automation demonstrates how the home appliances like fans, lights are controlled using sensors and a microcontroller. Basically, our components are affordable and simple. This makes the overall system reliable and cost effective, and this helps in the it makes suitable for the daily use. This is our conclusion, and here come to the references. We use this website for the ESP32 and DST11 tutorial, and also we use this website for the example project. And to know more about Wi-Fi and the sensor libraries, we use this service website. So overall, I conclude our project. Thank you.